Hi everyone. In this question we're going to be working on the 2015 AB Calculus AB as well as BC for response question number 4. Alright, so let's go ahead and get started. It says consider the differential equation dy over dx is equal to 2x minus y. First thing I'm going to notice is the fact that they gave me dy over dx. This right here lets me know this is a differential equation. So remember, if this is a differential equation, this is like y prime. I can find the slope. I can determine increasing, decreasing, things like that. So then for part A, it says, on the axis provided, sketch a slope field for the given differential equation at the 6 points indicated. This right here is one of my favorite questions. Why? Because it's the easiest. What they want you to do is to create a slope field. What is that? A field of different slopes. Well, how am I going to find these slopes? Well, I'm going to plug in these values, all these coordinates, into a differential equation, into a derivative so I can find slope. Why? Because derivative helps me find slope. So what I'm going to do is I'm going to take every single one of these points, and I'm going to plug it into here. So for example, we'll do 0, 1 first. Okay? So when we plug it in, what 0, 1, x is 0. So this is going to be at 0, 1. This is going to be 2 times 0, the x, minus 1, which is going to equal to negative 1. Which lets me know that my slope should be a negative line, something like that. Okay? We'll do another one. 1 over here. 1, negative 1. And this is going to be 2 times the x minus the y. So this is going to be 2 plus 1, which is going to equal to 3. Now, because this is my slope negative 1, I want it to be a little bit more steeper, so it should look something like this. Okay? And that's what you're going to do for all the other points. So eventually you should get things that look like that. Okay? So this is a horizontal line, okay? So every single time you have a question like this, just plug in the points and whatever your slope is, try to kind of estimate it to it could be as precise as possible. Okay, moving on to part B. Now this is where the question starts to get a little interesting. Part B says this: find d2y over dx squared. What does that mean? Second derivative. Well, what's my first derivative? My first derivative was the first derivative over here that was given to you in the original equation, 2x minus y. So if they want me to find the second derivative, I'm going to go, okay, well, I know that for b, dy over dx is equal to 2x minus y. So my second derivative is going to derive the left side, which is going to be that. And then when I derive the right side, remember, everything is respect to x. How do I know that? The denominator has dx. I'm going to find the derivative of 2x, which is 2. I'm going to find the derivative of y, which is technically negative 1. But because it's y, you got to remember, I need to add dy over dx, because every variable that you ever find a derivative of, if it's not x, when it's respect to x, you need to add d of that letter over dx. So I'm going to simplify this, make it a little bit nicer. This is going to be 2 minus dy over dx. Now, you will never be allowed to actually turn this answer in. It's not an acceptable answer. The reason why, we know what dy over dx is. What is it? Go back to the original equation. So every single time you have that, you have to plug it in. So 2 minus what dy over dx is equal to, which is 2x minus y. Distribute the negative, and you're going to get 2 minus 2x plus y. So let me write it again. 2 minus 2x plus y. And that right there is my second derivative. Okay? And being able to do that was 1 point. Now the next part of the question says, determine the concavity. What's concavity? Remember, taking values and plugging into your second derivative and determining if it's concave up or concave down. Determine the concavity of all solution curves for the differential equation in quadrant 2. So this is where we have to think about a little bit. Okay, quadrant 2. Quadrant 2, I'm going to pick a random point because I don't really know what values that are in quadrant 2. So let's just pick a random point. Negative 2, 1. Okay, that's my point right there. Well, let's think about it. Let's say we were to plug this into my equation. My second derivative is determining concavity. It's going to be 2, so let's do at negative 2, 1. 2 minus 2 times negative 2 plus 1. You should notice something that happens right here. The negatives are always going to cancel out to give you a positive. So it's really going to become 2 plus 4 plus 1, which is equal to 7, which is greater than 0, which means it's concave up. So does that happen every single time? Yes, because look at it. No matter what x you plug in the second quadrant, all the x's are going to be negative and all the y's are going to be positive. So therefore, you're always going to have an equation that's concave up. So the next part, for part B, when it says determine concavity, you're going to say concave up. and then it's going to ask you to give a reason for your answer. And you can say, because all, you can say coordinates in quadrant 2 have an x have an x that's less than 0 and y that's greater than 0. Okay? So that's part B. Now the one thing I don't want you to forget in part B is because in another question you will be asked to determine the second derivative, and don't forget, every time you find a derivative that's not in respect to x, you need to add a dy over dx and then plug in the original equation every single time. Okay? So moving on to part C. Well, part C says this. Part C says, let y equal f of x be the particular solution to differential equation with the initial condition f of 2 equals 3. Okay, initial condition f of 2 equals 3. I'm going to underline that. I'm probably going to need it. Then it says, does f have a relative min, relative max, or neither at x equals 2? Now, some of us want to go, okay, relative min, relative max at x equals 2. You want to find critical numbers because that's what you're taught to do. Remember, part C, the derivative which was given was dy over dx is equal to 2x minus y. Problem is, I can't really set that equal to 0 because I have two variables, so I'm a little confused. So, only thing that you have to remember is this. They just wanted you to determine what's going to happen at x equals 2. Well, let's go ahead and plug in 2 into my derivative. Well, what's the y coordinate? Well, they did give you that the initial coordinate at 2 was equal to 3. So let's plug those into there. So, at 2, 3, dy over dx is going to equal 2 times 2 minus 3, which is going to be 4 minus 3, which is going to equal to 1. Now think about it. What does it mean if I plug a coordinate into my derivative and I get a positive value? That means at 2, 3, it's increasing. Well, if it's increasing, there's no way it's going to be a min or max. Because how do I know if it's going to be a min or max? I have to get a value of 0, because a 0 would be a critical number. So because this does not equal to 0, this would be at 2, 3, f has neither a max slash min. Okay? So it's one of those things you kind of understand. Eventually, when you guys work on this question, you will think about setting the equation equal to 0, but because there's a variable, well, two different variables, you can't set equal to 0. So what you're going to have to do is you're going to have to plug in the points and determine what the slope is. Well, because I got a positive slope, it meant that it's increasing. Therefore, there's no way it could be a max or a min because it wasn't a critical number. How do I know it's a critical number? If it were to equal to 0. Okay? So let's move on to part D. Now, part D was the hardest part in this question. This question didn't receive that many points because of part D. Part D was something that a lot of students probably skipped on last year's exam. So I'm going to read it. It says, find the values of the constants m and b for which y equals mx plus b is a solution to the differential equation. Now, the one thing that you have to think about in calculus, you've been taught always set derivatives equal to derivatives to solve for a variable or original equations to original equations. They want me to find this m and this b that's a solution to this differential equation. Problem is, this is the original function. This is just y. How am I going to be able to find an m and a b of a differential equation? Some people would think about, oh, let's integrate this. No, let's not, because it's a little bit easier. Let's actually find the derivative of this and maybe set it equal to that derivative. So if I find for part D, once again, remember, dy over dx is equal to 2x minus y, and I get y equals mx plus b. If I find the derivative of y equals mx plus b, the derivative of mx would equal to m. Hopefully you guys know that. And remember, b is just a number. It's a constant. It tells you how much to go up and down on a line. That derivative is going to be 0. So I have dy over dx is equal to m. And then I also have on the other side, dy over dx is equal to 2x minus y. So why don't we just go ahead and actually set them equal to each other? Because since a derivative is equal to another derivative, that's going to be 2x minus y is equal to m. Now you're going to be like, okay, well, I'm kind of stuck because, once again, I have 1, 2, 3 random variables. And what I'm trying to solve for is I'm trying to solve for an m and a b. I don't want 3 random variables. So I'm going to go, okay, do I have an equation that tells me what one of those variables equals to? Hopefully you said yes, because you actually do. You actually have that y is equal to mx plus b. So wherever I see a y, I can plug this mx plus b into that y. Is it tough? Yes, absolutely 100%, okay? So it's one of those where you have to kind of be organized. I found the derivative of y equals mx plus b so I could set those two derivatives equal to each other, because since it's asking for a solution of a differential equation, I'm going to set two differential equations equal to each other. I got to this point, which is in red, but then I figured, how am I going to get rid of this y because there's so many random variables? Well, I do know that y is equal to mx plus b, so plug it back in. So this is going to lead me to here. 2x minus mx plus b is equal to m. Okay? And then I'm going to do a little bit of distributing, and I'm going to get 2x minus mx minus b is equal to m. Now, as of right now, I'm okay because I have that m and b now. Now I can actually go ahead and solve for an m and a b. I'm never going to touch the right side because this is the equation that they want me to find a solution for. So I'm going to go, okay, well, let's kind of work on the left side. If I work on the left side, maybe I can kind of take this out. Maybe I can take out an x, and if I do, this is what you're going to get. 2 minus m, and I'm going to take out an x. Minus b is equal to m. So let's think about it. Remember, they're looking for an m. They're looking for an m and a b for the y equals mx plus b. This actually is y equals mx plus b if you look at it. Y equals to something, the slope in front of x, plus b. So this is the number. So I'm going to go, well, let's make the right side kind of mirror that. And I'm going to do that by doing this. 2 minus m, x minus b is equal to, well, think about it. Do I have an x on this side? No, so let's make this 0x, and then let's just make this plus m. So if this left side is equal to this right side, that technically means, and hopefully you stay with me, that 2 minus m is equal to 0. So then I'm going to write that out. 2 minus m is equal to 0, but also minus b is equal to m. And I'm going to put that over here. Minus b is equal to m. And I'm going to ask myself, okay, which one's easier to solve for? Hopefully you said this one. If I go ahead and solve for this one, I'm going to get m is equal to 2. Perfect. Now I have m is equal to 2. And then the last thing is, well, how am I going to find this? Well, since I know m is equal to 2, plug it into here. Negative b is equal to 2. Therefore, b is equal to negative 2. And those are my two solutions. Okay? I'm going to get m is equal to 2 and b is equal to negative 2. How hard was this? Very hard. This was one of the hardest parts of a problem in the entire response section. Okay? So how did I even know what to do and how to do this? This is the reason. They asked you to find the values of the constants m and b for which y equals mx plus b is a, remember, is equal to a solution of a differential equation. This is a differential equation. This is differential equation, which means derivative equals to, I can't make this the original equation. I have to set a derivative equal to another derivative, and that's what I did here. And then once I had a derivative equals derivative, I didn't want this random y because I didn't have mx plus b here. None of that. So I took what y equal to, which was mx plus b, I plugged it in, solved for, simplified, and made things equal to each other. And it happened to work out. Okay? So, anytime you guys see a slope field, one of the easier questions. Okay? One of the easier questions. Just make sure you know how to plug in the points correctly. Anytime you're asked to find second derivative, find the derivative of the original equation, and if it ever has a y, make sure you put dy over dx. Alright? So, I want to thank you guys for watching. Hopefully it helped, and let me know how it went.